Hey, honors geometry students, Mr. Habel here. We're going to talk about the exterior angle of a circle. So, an exterior angle of a circle is outside of the circle. It's where the vertex is outside of the circle. So if we look at the diagram here, we have two secant lines that meet outside of the circle. We didn't draw in the full lines, we just drew in the segment portions of them. The lines would go on forever, but we're interested in where it starts on a circle, the secant hits the circle again, and then it goes outside of the circle. And then the other secant starts on the circle, that segment, and then it hits the circle and meets the other secant outside of the circle. So the vertex of an exterior angle is always going to be outside of the circle. So if we label these points A, B, C is the exterior angle, then we have point D, and we have point E. We're going to try to prove the relationship between the exterior angle and the two arcs that it forms. So that's the interesting part. If you look at the exterior angle, if you look at segment AC and segment EC, that exterior angle, let's call it theta, is responsible for two different arcs. The first intercepted arc is the large arc, which is on the opposite side of the circle. And then it's also responsible for the nearest arc, which is the smaller arc. And we say responsible, or we call those the intercepted arcs, because they're on the inside of angle ACE. They're on the interior of angle ACE. So in class, you did a notice and wonder on this. This notice and wonder is probably harder than the other ones. It's maybe not as intuitive. So what maybe you recognize in class is that the measure of the exterior angle is the large arc minus the small arc divided by 2. So if we called the large arc y and the small arc x, we're going to try to prove, or not try, we are going to prove that the exterior angle theta is equal to the large arc of y minus the small arc of x divided by 2. In everyday language, we'd say it's the measure of the large arc minus the measure of the small arc divided by 2. In the diagram, it's y minus x divided by 2. So this is what we're going to try to prove above, right? I keep saying trying to. We're going to prove that. All right, so how to prove that? This is kind of a cool one. This is creative. We can draw in, to prove it, we can draw in either chord AD or BE. I'm going to choose BE because chord AD kind of looks like it's pretty close to the center, and I don't want you to think that this would only happen if we drew in a diameter. Chord BE does not go through the center, so let's draw in chord BE. Now maybe you notice when you draw in chord BE that you get an inscribed angle. Angle ABE is inscribed because it's formed by two chords and the vertex of the angle is on the circle. And what we learned previously is that the measure of an inscribed angle is 1/2 of its intercepted arc. So if you look at angle angle ABE creates arc Y. So angle ABE must be 1/2 of Y. If I move down to angle BED, that's also an inscribed angle. Angle BED is inscribed as it's formed by two chords and its vertex is on the circle. The intercepted arc that angle BED creates is X, arc BD. So angle BED must be 1/2 of X. So if you've been watching the other videos, we tend to prove these just by using some of the triangle relationships. So if I look at this triangle BEC, I'll outline it in purple. Triangle BEC. We have two of the angles. We have one expressed as theta, one expressed as 1/2 of x. We don't quite have this other one until we notice that, oh, it's just the supplement of 1/2 of y. So angle EBC can be expressed as 180 minus 1/2 of y because of the supplementary relationship here. So the way that we're gonna prove that theta has to equal y minus x divided by 2, or the large arc minus the small arc divided by 2, is by adding up these three angle expressions. Because theta plus 1/2 of x plus 180 minus half of y have to sum to 180. So let's write that out. 1/2 of x plus 180 minus half of y plus theta has to be equal to 180. Notice a 180 on the left side of the equation and on the right side of the equation, so those would simplify to 0. I want to get theta by itself, so I'll move the 1/2 x to the opposite side. I'll add 1/2 y to move that to the opposite side of the equation. So now I have theta is equal to 1/2 of y minus 1/2 of x. If I factor out a half, then I have theta is equal to 1/2 of the quantity of y minus x. Well, multiply by half is the same as dividing by 2, so theta is equal to y minus x divided by 2. Now let's look in the picture. What's y again? Oh, y was the larger arc that was formed by the exterior angle. What is x? X is the smaller arc that was created by that exterior angle. So it's the measure of the large arc minus the measure of the small arc divided by 2. Thank you.